Hello all, this is Maunisha and welcome to this presentation. In this video, I am going to talk about mocking in unit testing. We all know about unit testing, what it means, how we do it, etc. So let's see what mocking is. In general terms, what does mocking mean? It means imitation, mimicking someone. But what is its use in unit testing? Well, we all know unit testing is all about testing an individual unit in isolation, but sometimes the units have external dependencies. In such cases, those dependencies are replaced by controlled replacement objects that imitate or simulate the behavior of the real ones. This process of replicating the real environment having actual external dependencies is called mocking. To isolate the behavior of an object you want to test, you replace the other objects by mocks that simulate the behavior of the real objects. This is useful if the real objects are impractical to incorporate into unit tests. Now that we know what mocking is, let us know why we need it. We need mocking in case of external dependencies like database connections, retrieving or pushing the data from or into the database. To explain in detail, assume that we are writing a unit test for a Java class where the purpose or role of the class is to establish a connection with the database and perform a database operation like retrieve or insert or create a database object and work with other entity classes, or to simplify, work with complementary other Java classes for the database objects. In this case, since a database is an external object to deal with, we consider mocking the database and work with a mock object instead. Mocking also makes the testing process faster. In a real world project that we work, there will be a lot of processing that happens in the middle layer, that is, in between the UI and the database. Let us assume a case where we have to write a unit test to a method which has dependencies on other class methods. It would be easy if the dependencies reach to 2 or 3 levels, but what if they reach to 17 levels down the line, which are nested calls and unavoidable? For a unit test, we definitely do not want all those processing to happen, and mocking really helps in this situation. One other reason why we need mocking is that mocks have a crucial difference from other testables. So I would like to mention here that mocks are not the only testables that we have. There are other types of testables like stubs, spy, etc. But mocks do a behavioral verification, whereas other testables do state verification. The advantage of behavioral verification is that you become able to test the implementation of the system under the test as you expect. On the other hand, state verification has no feature of testing the implementation of the system. In simple words, it just validates the inputs and outputs to the system. Let us see some mocking frameworks that help us to create mock objects. EasyMock is an open source framework that provides useful classes for mocking objects. It creates mock objects of classes and interfaces using the statically imported methods of the class extensions. So, we basically import methods that help us to create the mock objects. On the other hand, Mockito doesn't rely on static import features. It creates mock objects through annotations. It is used to register extensions for the annotated test class or test method. PowerMock, a framework which extends the existing frameworks like Mockito and EasyMock, is used to add more powerful features. It helps us to write good unit tests even for the most untestable code. For example, most of the mocking frameworks in the Java cannot mock static methods or final classes. But using PowerMock, we can mock almost any class. PowerMock currently extends the EasyMock and Mockito mocking frameworks. Depending on which extension is preferred, the syntax to write any unit test differs slightly. Let us see an example on how to use mocking while writing unit tests. For example, consider an interface calculator service which has a method declaration add which accepts two inputs, input 1 and input 2, which performs the addition of two numbers. And then there is a class math application which has an attribute of type calculator service, a setter method for that attribute, and a method add which takes two parameters and returns the result of their addition. Notice that this method body has an invocation to the interface method declaration add. Let us go through the unit test for the math application class. To demonstrate the usage of mocking, I am using EasyMock with JUnit here. @mock annotation helps us to create the mock objects of the classes. Now we have to add the behavior to the mocked object of calculator service. For this, we use the expect method from EasyMock, which helps us to add the behavior of calculator service to add two numbers. Another method, replay from EasyMock, activates the mock object. So this means that all the behaviors have to be added using expect and have to be activated by replaying them. After that, we did our general assertion to compare the expected results with the mocked object called result. Now let us try a little exercise. Take a moment and think where exactly we can use mocking while writing unit tests in our recent assignment, River Crossing Walk. I'll give you 5 seconds. Ready? Okay. We can use the mocking technique while writing unit tests for River GUI class since it has reference to the game engine interface. So instead of invoking the engine implementation and its methods, we can mock the game engine object and add the needed behavior to it and activate it as shown in the previous example. Let's see what sets the mock testing apart from the traditional unit testing. In traditional unit testing, unit tests do assertions about states expected of either the system under test or its dependencies. With mock testing, no assertions are required from the unit tests themselves. Assertions are done by the mock objects. These objects are initialized in advance about what method calls are expected and how they should respond. As the name suggests, mock testing focuses on how the fake or mock object can be incorporated and tested, whereas the traditional unit testing focuses on how the real object can be incorporated and tested. As mentioned before, while unit tests are more about state-based verification, mock testing is more about behavior-based verification. It means mocking would verify that the correct method was invoked with expected arguments. State-based verification means the verification of inputs and outputs. When we replay, mock registers the calls they receive so that these can be asserted. Let us discuss some of the good practices that we can follow while implementing mocking in unit tests. We should only mock the types that we own. Mostly, external types have dependencies on their own. They might even change their behavior in a future version. Instead, create an adapter and mock that adapter. When testing multiple modules, you should do integration testing rather than mocking. Relationships are made to view via interfaces easier instead of concrete classes. We would find mocking some methods, however, forget others. Mock roles, not objects. For example, we have created an interface for the calculator service which helps us to be free of the implementation details or changes to the underlying methods. Try to include one act per test instead of using multiple acts in writing the test code. Creating a separate test for each act ensures that the test is focused just on a single case and it can be known which act, if any test fail occurs. Mocks should be used to simulate errors and test error handling as well. Values must not be mocked. Mocking aims to create the relationships and interactions between visible objects. Obtaining a value isn't associated with the interaction. Do not mock everything. This is often associated with anti-patterns. If everything is mocked, we have a tendency to find testing one thing quite totally different from the production system. Naming standards explicitly express the contents of the test, so the name of the test must incorporate three parts: method name being tested, the testing scenario, and the expected behavior once invoked. And that's it. Some of the references or links that I have followed or mentioned here. You can go through these links if you need more information about the topics that I have covered. Thank you for watching.